Broadcast is now starting. All attendees are in listen-only mode.
Hi, my name is Heather Caliendo. I am a senior editor for Plastic Technology Magazine, and welcome to today's webinar sponsored by Matsui, Creating Highly Efficient Injection Molding Cells. So at any time during the broadcast, you can type in your questions directly into the webinar interface. And now, Bob and Dave, it's all yours.
Hi, my name is Bob Kazik. At Matsui America, I'm in sales. I primarily take care of the Southeast region of the United States and a little bit of the Midwest. I've been in the plastics industry since 1988. And a little bit of background about Matsui America. We're an auxiliary equipment supplier servicing injection and extrusion machine industry. And we're located in Hanover Park, Illinois, just outside Chicago. So that's where our North American headquarters, where we also have support staff, spare parts, service personnel, as well as engineering. And we've been in the United States since 1986.
Hi, I'm Dave Stapleton. I'm also a regional sales rep for Matsui. I handle the Northeast territory, which is about 14 states, and I've been in outside sales for over 20 years. We really appreciate you guys attending this seminar. Today, Bob and I will be reviewing what pieces of equipment make up a mold cell and what the basic differences from beside the press loading versus central loading system. And just so you're aware, this presentation will last between 30 and 40 minutes. Also, you will have the opportunity, as Heather said, to send us questions during our presentation. Please include your email so if we don't get a chance to answer them, we can respond later.
Today we'll be discussing how to create an effective injection molding machine cell. We will review the different types of equipment that should be selected and how to use this equipment together to help provide efficiency and consistency to your molding process.
After viewing today's webinar, you will be more knowledgeable about how to put together a molding cell for the best material flow, which equipment will give you a small footprint, and most importantly to everybody, I'm sure, is low energy costs. Hey, Bob, I've heard you say that no two molding shops are the same. You're referring to factories that you would consider putting together a mold cell, right?
Yeah, different facilities. Every facility is set up in a unique and different way. Traditionally, in the plastics industries, there's been two choices when setting up your facility, and one would be to use beside the press equipment, individual pieces of equipment beside the injection machine. The other would be to use a central material system. And things that you should consider when trying to choose between the two would be how many injection machines do you have? Do you have 2 injection machines, 3 injection machines, 10? How many machines do you anticipate getting in the future? Also, the distances, are the injection machines spread out? Are they in different parts of the facility? Are they all close together? So, consider how far apart the injection machines are as well. How many materials will be used? Will you be using just 1 or 2 materials, a polypropylene or a polystyrene? Or maybe you're a custom molder and you'll be using a variety of different materials, maybe polycarbonate, ABS, nylon. So how many different materials are you going to be using? Will any regrind be used? Do you plan on reprocessing and reintroducing regrind back into your system? Also, will there be a lot of material or color changes? Are you going to be changing molds a lot? Will you be changing materials and or colors a lot? How much floor space is available? Also, what is the available budget that you have? And we could go into a whole separate webinar about the advantages and disadvantages of each type of setup. But today in this webinar, we're just going to focus on beside the press injection molding machine cell equipment. But I will say this, I have seen people who have bought beside the press equipment to incorporate into an existing central material system. I've also seen people who have used existing beside the press equipment to incorporate with a new central loading system. So it doesn't necessarily have to be one or the other. The equipment between the two types of setups can be intermatched or mixed with each other. But today we will be focusing on injection molding machine cells beside the press equipment.
During this next segment, beside the press equipment, we'll look at basic equipment configuration of a typical cell, like a standard molding cell, along with options for more of an enhanced molding cell.
Right, in our standard configuration, which will consist of the necessary basic pieces of equipment. Obviously, there will be an injection machine, a dehumidifying dryer, a material loaders to load material from point A to point B, and mold temperature controllers. Then we'll also get into an enhanced configuration, and this will be adding components which will allow regrind to be reused.
Such as a granulator, a regrind ratio valve, and a blending hopper for virgin and regrind. So let's start building our mold cell. By the end of this seminar, we'll have filled in all of the pieces of the puzzle for an efficiently designed mold cell. But let's start with the basics. Let's start with the dryer. For example, how do you pick one out? What options do you consider? Let's begin by discussing some of these things.
Well, the first question is, why are dryers needed? And in the plastics industry, there's two types of material, two types of resin. One would be non-hygroscopic resins, those that don't retain moisture, such as polypropylene or polystyrene. The other would be hygroscopic resins. These are more the engineered materials that retain moisture, such as ABS, polycarbonate, nylon, acetal. These materials retain moisture, and dehumidifying dryers are needed to remove moisture from the plastic. Failure to remove the moisture can affect your parts. It can affect the tensile strength and, as well as cosmetic appearance of your parts. So dehumidifying dryers are needed to remove moisture from hygroscopic resins. So the first thing that you should determine when you're trying to decide about a dryer would be, what's your estimated pounds per hour rate. If you know what your cycle time and shot weight is, that's ideal. You will get your exact pounds per hour rate. You might be a custom molder. You're going to be running different molds. In that case, try to estimate your pounds per hour rate based on your largest mold, what your biggest throughput would be. And the reason the pounds per hour rate is important is there's many different size dryers with different drying hopper capacities based on throughput. You don't want to buy a dryer that's too small, that's not going to keep up with the pounds per hour rate of the injection machine, that's not going to adequately dry material. And you also don't want to buy a dryer that's too big, because it'll just be using too much energy, and also it can run the risk of over drying certain materials. So, coming up with an accurate estimate of what your maximum pounds per hour rate is important. Also, what types of materials are going to be dried? Will it just be one or two different materials? Again, maybe you're a custom molder and you could be running, ABS in one mold, nylon in another, PBT in another mold. So what type or types of materials will you be drying? If you are drying several different types, what is the most difficult material to dry? Take a worst case scenario, and what would be your most difficult material to dry, which 9 times out of 10, it's usually a nylon material. Also, will any regrind be used? Are you going to be reprocessing any of the regrind? And if so, what percentage of regrind? Now, it's not so much that regrind is more difficult to dry. It can be if you leave it in storage for a long period of time, where it can reabsorb moisture. And sometimes if the beginning or initial moisture content is too high, it can't even be dried if it's exposed too long. But the main concern with regrind is regrind has a lot of dust and fines, and it also has a lot of miscut shaped material. So it's not in a uniform pellet size, but a lot of miscut pieces. And the dust and fines, as well as the miscut pieces, can impede airflow. So, airflow through the drying hopper is always very important for a dryer. If regrind is impeding that airflow, you might have to dry material for a little bit longer if larger percents of regrind are being used. But these are all pieces of information that you should have prepared when trying to size and decide for a dehumidifying dryer.
And now let's look at a few of the more important features that you would be looking for when you're purchasing a dryer.
Things to consider when purchasing a dryer or looking into purchasing a dryer would be performance. How much will the unit dry? What is the pounds per hour rate that it can handle? The residence time. How long will it take to dry a certain your particular resin? Will it take 4 hours to dry ABS? Will it take 4 to 6 hours to dry nylon? What is the performance and how long will it take to dry your particular material? Also, efficiency. How much energy will the unit consume? Standard features. What's available on the unit? Does it have a stainless steel drying hopper? Does it have an aftercooler? Does it have a discharge damper? What are the standard features that are on the unit? Dependability. Will it deliver consistent results from day one to 10 years down the road? You want something that's going to deliver consistent, dependable results day after day, week after week, year after year. Durability. Are quality components being used? Will it last a long time? Ease of maintenance. Is it easy to maintain? What spare parts are needed? Can you get those spare parts quickly? Can you get a service tech on the phone if you have any questions or need assistance? Also, footprint. We're going to be using our dryer in a molding cell, so we don't want it to take up a lot of space.
Okay, from here, let's get into the key features of the Matsui MJ5. Let's see how they compare against the qualities that Bob just laid out for us.
The MJ5i is a dehumidifying unit that we offer. It's actually a combination dehumidifying dryer vacuum loader. And some of the key benefits, features of it that we'll go into in a little more detail are the desiccant rotor technology that we use, which helps to lead to stable dew points and also reduce drying times. It has an I-Plus energy saving feature, which will help to save energy and prevent over drying of certain materials. It has a small footprint and also a programmable timer that can be used. The heart of the MJ5i dryer is our desiccant rotor. It's a one piece desiccant rotor that would be inside our MJ5i unit. And this rotor is separated into 3 sections. And one is the dehumidification zone, dehumidifying zone, where air from the drying hopper is sent through the desiccant to remove moisture from that air. And then low dry dew point air is then sent to the drying hopper. The dew point of the air refers to the dryness of the air. So the lower the dew point, the more dry or the more thirsty the air will be, and the better job it will do of removing moisture from the plastic resin. So you always want the dryer to be providing low, dry, thirsty air to the drying hopper. So the return air comes from the drying hopper, goes through the desiccant rotor to remove moisture. After there's moisture in the desiccant, it needs to be regenerated. So during the regeneration zone, air is heated to a higher temperature to purge moisture from the desiccant. After the desiccant is regenerated, it's then cooled and before being put online again. So our desiccant rotor is always turning. It rotates about 8 revolutions per hour. So it's always feeding fresh desiccant. It's always regenerating. It's always cooling down. There's never any switching of desiccant beds. Traditionally in the plastics industry, the most popular type of dryer has been the desiccant bead type dryer. And these have small desiccant beads which are tightly packed into canisters. And there will be several canisters. One setup is a 2-bed system where one bed would be online drying, the other bed would be offline regenerating. And then there's also carousel type setups where there's 3 or more desiccant beds that rotate, and they always rotate usually by timer or dew point demand. A concern is whenever the desiccant beds rotate or switch, there's a fluctuation in the dew point. The dew point level will spike before dropping again. And the issue is all the material, all the plastic resin as it goes through the drying hopper doesn't have consistent low dew point air going over it. It has a fluctuating airflow on the dew point going over it. Where our desiccant rotor slowly rotates, again about 8 revolutions per hour, so there's never any switching of desiccant beds. So it always provides a very low and stable dew point. So all the material, as it goes through the drying hopper, has low, stable dew point air going over it. We also use a flat desiccant surface compared to a round desiccant bead. The desiccant rotor is it's a substrate with the molecular sieves bonded or baked to it, and it's like a corrugated shaped form. And the flat desiccant surface allows us to have a higher air to desiccant ratio. So we can pull more moisture out of the air as it passes through compared to a round desiccant bead. Imagine if you spilled some coffee or water on a table, you would use a flat paper towel to soak up that moisture as opposed to a round sponge because the absorption would be much better. Also, during regeneration, our flat desiccant surface allows us to regenerate the desiccant quicker using less energy. Imagine if you were going to dry a t-shirt out in the summertime. You would spread out that t-shirt and put it on a clothesline because it would dry out much faster than if you crumpled that t-shirt into a ball and left it on the ground. So that's the same concept that we use with our flat desiccant surface. We have a higher air to desiccant ratio to pull more moisture out of the airstream, and it's also very easy and energy efficient to purge moisture out of the desiccant. So the combination of the low and stable dew point, along with the higher desiccant ratio, air to desiccant ratio, allows us to dry materials quicker than desiccant bead type dryers. So we can dry materials, most materials, in about 2 to 4 hours. Desiccant bead type dryers, resin material manufacturers will recommend drying time based on desiccant bead technologies. They'll be somewhat conservative in their estimates because they don't want to get calls from customers thinking there's a problem with the resin when actually it's a dryer problem. So their drying recommendations for the different materials will be somewhat conservative, and they're based on the desiccant bead technology. Where because of our desiccant rotor, because of the low and stable dew point, we can pull more moisture out of the air. We can dry most materials in about 2 hours. So that can lead to energy savings because it's drying the same amount of material but with a smaller unit. So the overall kilowatts of the heater and blowers will be smaller. Also, the footprint will be smaller. Say you want to dry 100 pounds per hour of ABS. Instead of needing 4 hours to dry it and having to have a 400-pound drying hopper, the MJ5i can dry it in 2 hours and would only need a 200-pound drying hopper. So the physical size of the unit will be much smaller, which is important when using it in an injection molding machine cell beside the press. Also, the MJ5i has I-Class I-Class energy savings, and what that is that it constantly measures the return air temperature coming back from the drying hopper. So, in a normal production scenario, the drying hopper is going to be discharging material to the injection machine. As that material is discharged, new material will come in from a Gaylord to fill up the drying hopper again. So, and that'll be constantly going on as you're running production. Say something happens to the injection machine, the machine alarms out, something happens, some maintenance has to be done on it. That means no material will be discharged from the vacuum hopper to the injection machine. Also, no new material will come from the Gaylord to the drying hopper. That means the material will just sit inside the drying hopper. It's stagnant. And so the temperature in that drying hopper is going to go up. It's going to increase. So the MJ5i unit monitors that return air temperature. So when it senses an increase in temperature, it knows the material is stagnant inside the drying hopper. So through a motor inverter, the unit will automatically slow down the blowers and heaters to save energy. So you're not running the unit at 100% capacity when you don't have to. It'll slow the unit down. And then when the injection machine begins to run again, when material is discharged from the drying hopper to the machine, when new material, which causes the material level to go down inside the drying hopper. So then new material from the Gaylord would be conveyed to the drying hopper. At that point, it would sense a decrease in the return air temperature and then ramp the unit back up to 100%. So it will automatically monitor this and automatically adjust the unit. It'll slow down the unit when necessary and then speed it back up when it senses a drop in temperature, meaning production is running again. Also, this feature can protect against over drying of certain materials. Materials like PET and nylon can be over dried. If they're dried too long, they can discolor, they can become brittle. So the I-Class energy saving feature will also help to protect against over drying of certain resins. Also, the unit has a programmable timer on it. So it's a calendar timer that you could program the unit to be turned on and off several times during the week. Most people use it as a startup timer. So if you want the unit to turn on at 3 a.m., so your production run is at 5 a.m., you want it to turn on at 3, so you have nice dried material by the time production starts. You could program the unit to turn on at 3 a.m. instead of having an individual that has to come in and turn all the dryers on. You can just simply program a timer to do that. Also, I wanted to touch on desiccant replacement. The desiccant rotor is a beadless type dryer. There's no desiccant beads to replace. It's a substrate material, molecular sieves are bonded or baked to it. So there's no desiccant beads to replace. Desiccant beads that are packed in canisters will degrade over time. Those desiccant beads will soak up with moisture and depending on usage, usually have to be replaced every 1, 3 to 5 years. And that can be expensive and time consuming to repack all the desiccant beds. With the desiccant rotor, there's no desiccant beads to replace. Under proper maintenance, the desiccant rotor will last the lifetime of the unit. So replacing desiccant can be a thing of the past. Also, there's a lot of vertical structured paths in our desiccant rotor, so it's very easy to push the air through. With the desiccant beads packed in canisters, the air is forced through at a high rate, and that can cause friction of the beads against each other, which can cause a powdering effect. That powdering can shift through the desiccant bag and clog air passages, so the entire desiccant isn't being used. Also, some of that powdering can get can circulate through the dryer system and can contaminate the resin inside the drying hopper, where with the desiccant rotor, there's no desiccant beads, there's no powdering of the desiccant, and it's less maintenance because the desiccant doesn't have to be replaced.
Okay, now that Bob has gone over the MJ5i and the desiccant rotor part of the dryer, let's talk a little bit more about that, because that dryer has two functions. It not only dries the material, but it can also transmit it to the injection molding machine.
Right, so we have our drying hopper, we have our dehumidifying dryer. The next part would be to convey material from the Gaylord to the drying hopper, also from the drying hopper to the injection machine. And in the plastics industry, there's basically two types of material conveyors that are available. And one is compressed air. Compressed air will use compressed air, positive air, to convey material from point A to point B. And it's a relatively simple and inexpensive way to convey material. Some concerns about compressed air loaders would be throughput. They're normally better when used with smaller throughputs, maybe 150, 100 pounds per hour and under. Also, the filtration on compressed air loaders, they don't have a very big filtration area, so the dust and fines removal, if you're going to be running regrind or glass filled material, the fines removal capability is somewhat limited. An alternative to compressed air loaders would be vacuum loading. And one type of vacuum loader is a single phase self-contained brush type motor. And it's a self-contained unit. It would sit on top of wherever you're conveying to, on top of a drying hopper, on top of the injection machine. And some of the issues with these types of loaders are the brushes have to be replaced fairly often. The motors can burn out if the material is dusty or using high percentages of regrind. It uses a flat pancake filter, so the filtration area for dust removal, again, is not all that great, somewhat limited. And then an alternative, a different type of vacuum loader would be a three-phase ring compressor. And that's what our MJ5i combination dryer loader uses as its vacuum source, a three-phase ring compressor. So there's no brushes that have to be replaced. The ring compressor is going to last a very long time. And we use it in conjunction with a cyclone filter. So when vacuum is applied in our vacuum receiving hoppers, we have punch plate screen filters. This allows for the resin to stay in the vacuum hopper, and dust and fines are removed through that screen when the vacuum is applied. And then all the dust and fines will be collected in a cyclone filter, which does a very good job at removing dust and fines from the process. Also, something else that we have that's a real nice feature is a normally closed discharge damper. And whether you're looking at our dryer or someone else's, this is a nice feature to try to make sure that the dryer will have. What it is, it's placed at the bottom of the drying hopper, and it's a normally closed discharge damper controlled by a timer that you can adjust based on your injection machine throughput and shot size. So when the injection machine calls for material, that valve will open based on whatever the timer is set for, and it will discharge material. If the timer is set for 2 or 3 seconds, it'll discharge material for 2 or 3 seconds and then close again. Then vacuum is applied to convey all that material to the vacuum receiving hopper on the injection machine. So there's never any material remaining in the material line or in the vacuum box after each conveying cycle. When you dry material in your drying hopper, you want to limit the amount of exposure that it has after it leaves the drying hopper to the injection machine. You want to reuse that material as quickly as you can, especially if it's a very moisture sensitive material like PET or like nylon, which can reabsorb moisture fairly quickly. So the discharge damper enables a prescribed amount of material to be conveyed to the injection machine with each conveying cycle. All the material complete conveyance of the resin will go to the injection machine. So that will do a very good job at reducing the amount of time the material is exposed for after it leaves the drying hopper. In our standard configuration, the MJ5 will load from a Gaylord to the drying hopper, and then from the drying hopper, where again our discharge damper will be at the bottom of the drying hopper, it will then convey from drying hopper to the injection machine, and it also has the capabilities of feeding up to 4 injection machines. So you could feed up to 4 machines with one unit. Also, it has a very easy to clean out design. It has a large clean out door. The drying hopper is made of stainless steel, and the discharge damper comes apart easily. So if you're going to be doing a lot of material or color changes, it's easy to clean out.
So now that we've talked about Matsui MJ5i dryer portion of it and the MJ5i vacuum loading portion of it, let's get into our mold temperature controllers.
Okay, so we have our dryer, we have our material loaders. The next part in our standard configuration would be our mold temperature controller. And the mold temperature controller will usually work in conjunction with a chiller and will circulate water to and from the mold to keep the mold at a consistent temperature to provide consistency to your process. So things to consider when trying to decide or size up a mold temperature controller, the first would be temperature. What temperature do you want to run your mold at? If it's going to be, you're a custom molder, different materials, different molds, what is the highest temperature that you're going to run your mold at? And the reason for that is there's different types of units, water medium, oil medium. Water units can go to 200 degrees, 250 degrees Fahrenheit. Higher temperatures might require an oil medium. So having your target temperature is the first thing that you should consider when trying to choose a mold temperature controller. Another would be the tonnage of your injection machine. Do you have a 200-ton machine? Is it a 400-ton? Also, the flow rate. Is the particular mold you're running, does it have a particular flow rate that's required, a specific GPM rate? So temperature, tonnage, and flow rate requirements, you should have an idea of these when choosing a mold temperature controller.
Here's some of the factors that need answers before you figure out exactly which model to get.
Well, our MC5 unit uses a high pressure pump, which uses a low volume of water. So it's a high pressure pump. It reaches target temperatures faster, shortening startup times. It has a small footprint, which is important in our injection molding machine cell. It has casters for portability, stainless steel and copper components, can store up to 64 temperature settings. It has valves and manifolds complete on the unit, so you don't have to worry about fabricating your own. The unit comes with the valves and manifolds already on it. It has a bypass valve and a pressure gauge as well. The bypass valve is real nice where, say you're switching from one mold to a smaller mold, and you can open up that bypass valve to allow some water to bleed off, and that will alleviate pressure on the pump. So it'll prolong the life cycle of the pump, and also you won't have to change pump seals out as often. Also, our G3 model comes with SPI and Modbus communication options.
So now that we've talked about the MJ5i dryer, the MC5 mold temp controllers, those are your basics for your typical mold cell. Let's start talking about the enhanced molding cell and add the granulator.
Okay, granulation. Why would you want to regrind or grind up your material? One reason, or One reason to want to reuse regrind would be to reduce the amount of scrap that you throw out. It's more environmental friendly. The other reason would be to save money. The more regrind that you can recapture and reuse, the less virgin material that would be needed, so that it can cut costs on your raw material costs. So things to consider if you're going to be wanting to granulate or use regrind would be, what is your sprue and runner dimensions? What are the biggest sprue and runner and or defect parts that you would be grinding up? Not just the width and the length, but also the thickness of the runner. The pounds per hour rate, or how many, what's your cycle time? How many sprues are generated per minute per hour? What are the types of materials you want to grind up? Is it a soft material like a TPE or a TPU? Is it more of a basic material like an ABS? Does the material have any fillers? Maybe it's a glass filled nylon, 30-40% glass filled. Maybe it's a talc filled polypropylene. So size of the overall runner, that the biggest runner you want to put in the unit, the types of materials, and if the materials have any fillers, are all important information that you should gather beforehand. And for granulating in the plastics industry, there's two ways that you can grind it up. One would be using a high-speed granulator. The other would be using a low-speed granulator. The high-speed granulator, they're usually kept in a central grinding area. So sprues and runners are then collected from each injection machine, then taken over to the central grinding area where the material is then grinded up. Some concerns with high-speed grinders is they grind the material at a high rate of speed. And when this is done, a lot of dust and fines are generated. Also, there's a lot of miscut shaped material for the regrind. The regrind's not in a consistent uniform shape. There's a lot of miscut pieces. So then this regrind material would be taken back to the injection machine to be reused, put in gaylords or material tanks.
Sorry, Bob.
Used in gaylords or material tanks. And so the problem with some of the high-speed grinders is the dust and fine generation, as well as the miscut pieces. Now the miscut pieces are non-uniform shape, can have problems with both the conveying and the drying process. A lot of dust or misshaped regrind can clog material lines. It can also affect the drying process. If there's a lot of miscut, dusty material in the drying hopper, that can impede airflow going through the drying hopper. So the material might have to be dried for a longer period of time. An alternative to high-speed grinding would be a low-speed grinder. And a low-speed grinder will cut the material or grind the material at a lower rate of speed. So by doing so, it will reduce the amount of dust and fines generated, and it will also help to create a more uniform shaped regrind pellet, which will assist both with the drying and conveying processes. Also, a low-speed grinder is small enough, quiet enough that it can be used within our injection molding machine cell. Ideally, the runners, sprues are fed by a sprue picking robot or a regular traversing robot or even a conveyor. So each cycle, a sprue or runner would be dropped into the low-speed grinder. It would grind that material up. And we're grinding the material right next to the injection machine, so that material can be reused right away. Sometimes it doesn't have to be re-dried. You can take that material and send it back with the virgin material to the drying hopper, or if it's being used fast enough, the regrind material will not have to be re-dried, and you can just blend it with the virgin material, go into the injection machine feed throat.
Okay, sorry about that. Quick trigger finger there.
Matsui offers a SMGL3 low-speed grinder, which can mount within our molding cell right next to the injection machine. So it's low speed. It'll produce high quality, consistent regrind. Will reduce the amount of dust and fines generated. It's energy efficient. It's very quiet compared to high speed grinders. They're very easy to clean. The cutting chamber collapses completely open for easy clean out. The regrind can be used right away. It also has magnet protection on the feed hopper. So the magnet on the feed hopper will help to protect the cutting chamber from any metal contaminants. Also has a very small footprint. Again, can be used right next to the molding machine and within our injection molding machine cell.
Okay, so now that we have the virgin material from the dryer and the regrind from the granulator, let's look to see how we would mix the materials together using the ratio valve, which is right here.
So a rationing valve is a relatively simple and inexpensive way to ration virgin and regrind material together. And the rationing valve is a pneumatic valve. It has timers on it, so that valve will switch back and forth depending on the timer settings to ration in your regrind material with your virgin material. So you can ration that material back to the drying hopper. You can ration it directly to the injection molding machine, the vacuum hopper that's on the injection molding machine. They're ideal to use in situations where you're producing less regrind than the maximum amount allowed. If you have to run a more consistent mix, say your customer wants you to run 80% virgin, 20% regrind, 70% virgin, 30% regrind, and that mix has to be exact each and every time. A rationing valve probably doesn't have the accuracy to do that, and you would at this point want to go to a volumetric or gravimetric blender. But for a small, compact, simple, inexpensive way to ration virgin regrind material, a rationing valve is a good choice. And what Matsui America offers is a JSV 38 and JSV 50 rationing valve that can be used in conjunction with our MJ5i combination dehumidifying dryer and vacuum loader, as well with our separate vacuum loader units.
So now that we've got the virgin material and the regrind material mixed together, we need to make sure that they're going to mix together properly in the mold.
So right, we're rationing our virgin and regrind material together, and that material is being sent to the injection machine. And what you want to prevent from happening is layering of the virgin and regrind material. If the material is layered too much, that means some of your parts might have a higher concentration of regrind that you want, and that can cause those parts to be defective. So you don't want the layering of virgin and regrind material as it enters the injection machine feed screw. So an exclusive Matsui design is our APH vacuum hopper, which would mount directly on the feed throat of the injection machine. The material port is about halfway up the side of the unit, and the vacuum port is on top of the unit. Between those two chambers is a flapper, so when the vacuum is applied, that flapper will seal shut, and it will allow material to be percolated in the top chamber of the vacuum hopper. So that material is being percolated or mixed. So it's preventing layering of virgin and regrind material. It's mixing those two materials together. Also, it's percolating the material, giving the material an air bath. So all the dust and fine particles, as the vacuum is being applied, are being pulled through our screen filter back to our cyclone filter, whether it be on our combination dryer loader unit or just on our vacuum loader. So it does a very good job at preventing layering of virgin and regrind material, and also will clean that material right before it enters the injection machine feed screw. So a lot of customers who are running clear polycarbonate acrylic parts have been using this with great success, to avoid black spot dust contamination. So, the APH vacuum hopper used in conjunction with our rationing valve will provide a good blend of the virgin regrind material and also do a very good job at removing dust and fines from the process before the material enters the machine screw. Dust and fines can be problematic because they can burn quicker during the melting process, and those speck can show up on the part and cause defects. So dust removal, preventing of layering of virgin and regrind material are all important considerations to have during the last stage of the material handling process.
And speaking of the last stage, so far we've gone through everything. We've gone through the Matsui dryer, we've gone through the granulator, we've gone through the mold temp controllers, the rationing valve, and the aero power hopper.
Right. So we got a dehumidifying dryer, or actually our combination dryer and loader. So we're moving material from Gaylord to drying hopper, from drying hopper to injection machine. We got our discharge damper for complete conveyance of resin to the injection machine. We have mold temperature controller to control the consistent temperature of the mold. Then we'll be adding a low speed grinder along with a rationing valve and our APH vacuum hopper to blend the virgin and regrind together. So that's basically it for the presentation part. Again, thank you for attending this webinar. I hope this was helpful for you. We will put up our contact information and open up for questions, I believe, correct?
Correct.
Yes,
Okay.
yes. Great. All right, perfect. Well, thank you all. All right, yeah, let's get into the questions. And of course, if anyone who's attending has any questions, now's the time to type it into your webinar interface. So we got some already, so let's get started. So how often must I change out the desiccant rotor on my MJ5 dryer?
Under normal circumstances, again, there's no desiccant beads to replace on the desiccant, and the desiccant rotor is not a normal replacement item. We've been selling desiccant rotor dryers since 1988, and there's still units from the late 80s and early 90s that are being used with their original desiccant in them. So it's not a normal replacement item. As long as you maintain your filters somewhat halfway decently, you don't have to worry about replacing your desiccant. A dryer, our dryer, any piece of equipment, it's like a car. If you buy a car, you never get your oil changed, don't do any preventative maintenance on it, it's going to break down much faster. But again, the desiccant rotor doesn't have to be replaced. It's not a normal replacement item. You would have to seriously neglect maintenance and care on the unit to damage the desiccant rotor. So it's not a normal replacement item. You can replace it. It can be replaced, but it's not something that you would have to worry about.
Okay. Is there an upcharge to order the machines at 230 volts instead of 460 volts?
There would not. In North America, United States, it'd be nice if everything was one standard voltage, but it's not. We have some customers who run 460 volt, 480 volt. Some run 208, 230 volt. So we carry equipment in both voltages, both 460 and 230. But there's no price difference between the two. The price of a 460 volt unit is the same price as a 230 volt unit.
Okay, what are the available capacity ranges for the MJ5 dryer?
The MJ5i has 4 different models. The smallest is a 65-pound capacity drying hopper. Next would be a 130-pound capacity drying hopper. Then a 260-pound capacity hopper, And then the largest is a 660-pound capacity drying hopper, which we actually can add an extension ring to make it 880 pounds. So the largest drying hopper capacity on the MJ5i series is 880 pounds.
Mhm. Okay, so except for nylon, what are some of the other polymers that need to be dried very well?
Besides nylon,
Yes.
most engineered resins, ABS, PBT, PET, PEEK. There's a variety, and there's so many different types of materials, different engineered materials. It's hard to keep up with the new types and the new blends, PC ABS blend. Um, but most of the engineered materials coming out today need to be dried, and also especially in the packaging industry, you're seeing more newer type resins like PLA, biodegradable resins, um, that are also becoming more popular. And for drying those materials, usually it's done at a lower drying temperature rather than a higher drying temperature. But most engineered materials would have to be dried. If you're unsure if the material you're using has to be dried or not, probably your best source would be to call the resin manufacturer and find out from them if you have to dry it, and they would be able to give you some guidance on their recommended drying time as well as the recommended drying temperature. You depending on the resin, you can, if you're drying the material at a high enough temperature, you're not going to remove moisture. And if you dry it too high on a low temp resin, you might, start to bridge or have bridging problems in the drying hopper. So your material supplier will be able to tell you if the material should be dried based on your what you're producing, your product, and also at what temperature.
Mhm. Okay. Okay, great. So do you recommend drying a blend of virgin and regrind? Do you expect any sort of separation inside the hopper?
Um, no, I mean, our APH vacuum hopper that's on the press that will prevent well, I guess the question is probably they're referring to different weight. Like if the weight of the regrind material is in a bigger form, would it be heavier? And therefore cause separation during probably the conveying process. I guess to answer that is you would have maybe a bigger problem of that happening in a central loading system where you were conveying greater distances. The greater distance, the more of a risk or chance that separation could happen. If you're doing it within an injection molding machine cell, the conveying distances would be fairly short. So you shouldn't have a big problem. And again, if you use a low speed grinder that has a smaller, consistent shape regrind pellet, all the conveying is done within the injection molding machine cell, you shouldn't see any problems with separation. No.
Mhm. Okay, so what RPM is the low speed grinder?
I believe ours is 28. I believe most RPMs, the slower speed grinders, are around 28 to 30 RPMs.
Mhm. And what is the recommended screen hole size?
Um, our I should have touched on that. That's a very good question. Our low speed grinders are screenless. There's no screen. They're screenless grinders. They have larger cutters that will break the runner's sprues down into smaller pieces, then smaller cutters that will create a smaller regrind pellet. The average size is about 5 by 6 millimeter pellet that is produced on our slow speed grinders, 5 by 5 millimeter to 5 by 6 millimeter. So it's a screenless grinder. There's no screen, and it will produce about a 5 by 5 to 5.6 millimeter shape pellet.
Mhm. Okay. Okay. Do you have a particular equipment or setting settings for the use of post-consumer recycled pellets?
Post-consumer again. Okay, so regrind. What was the first part of the question?
Yes, sorry. Yeah, I felt there's a bit of echo. Okay, do you have particular equipment or settings for the use of post-consumer recycled pellets?
Okay, so post-consumer regrind. That's usually referred to like the bottle packaging industry. And a lot of time it depends on if the bottle or preform is grinded. When you grind up bottles, you create flake material. Material can be more difficult to convey, especially if you're going to be using 20, 30%, 40% flake material. You might have to get, material loaders or vacuum lines that have bigger diameter. Otherwise, it might easily clog up 1.5 or 2 inch material lines. But a lot of times that flake material will be remelted and repelletized. So if it's repelletized, no, you could, use standard equipment with repelletized PET. If it's in flake form, if the PCR post-consumer regrind is in flake form and a high percentages of flake are being used, then you might have to go to a different type of, not so much a dryer, but maybe a conveyor with some bigger material lines, bigger vacuum lines to prevent clogging of the resin in those lines.
Mm-hmm. Okay, so it looks like we have time for one more, so I'll fit one more in real quick. So what about moisture being added in the APH blended hopper?
That's, it's a good question where you want to limit the exposure of the material after it's been dried. But for example, our MJ5 is using closed loop air to percolate that material, so it's not using external air to do that. So that helps to keep the material dry, the resin in the vacuum hopper dry. Also, that discharge damper will allow you to just convey a small amount of material to the vacuum hopper, the APH vacuum hopper. Again, you want to keep enough material in the APH vacuum hopper or whatever vacuum hopper is on the feed throat. You want to keep enough material there that you're not starving the injection machine, but you don't want to keep too much material there that you're going to run the risk of the moisture of the material reabsorbing moisture. So depending on your throughput, your pounds per hour rate, what the material is, we can help you find that happy medium of the correct amount of material to keep in that vacuum hopper so you don't reabsorb moisture. So no, the APH, as long as the discharge damper conveying times are set properly, there won't be any issues with the material reabsorbing moisture, unless it's like an isoplast material that's super, super moisture sensitive. But even our standard units have been used with that material. And again, as long as the settings are set correctly, then it should be no problem.
And in the APH, it's completely enclosed. There's no open air.
Mm-hmm. Okay, well, great. Well, we're at the top of the hour. So again, the speaker's contact information is up on your screen if you all have any additional questions. I'd like to thank Bob and Dave for this great presentation.
Thank you.
Thank you. Matsui for sponsoring today's event, and all the attendees for joining us. You will be emailed a link to a recording of the presentation, and it will also be posted to ptonline.com. Thank you, and have a great day.
Thank you.
Thanks, Tori and Heather.